Well, good morning, sixth grade. You guys did such an awesome job with your um, finding speed lab yesterday. Dee Dee, I had to laugh really hard at the things that you were judging the speed of, like a shoe flying across the room and a water bottle and a marker. That cracked me up a lot, but I love your creativity and doing what you can with what you have, so that's awesome. But good job, guys. So just a quick review. We've been talking about motion and the relationship between distance, time, and speed, and you guys have all been using this. We've been figuring out our distance. In order to do that, we take speed and multiply it by times. Anytime you see it next to each other, you know it's multiplication. If we want to try and find time, we know it's distance divided by speed. You can think of this as your division line. And then if we're looking for speed, we take distance divided by time, as you can see with this over here. And then you also had to do these questions over here. And for the most part, you guys did really well. Some of you need to watch out with how you are, how you're multiplying and dividing, especially dividing. Make sure that you guys are putting the correct number in the right spot. And you can see these are the answers. You can see for the number 1, we take kilometers per hour. And again, make sure you guys are labeling your answers. In order to label your answer correctly, you need to make sure that you're taking whatever's already listed in there. If it's asking for kilometers, you know that your labeling is going to be kilometers. If it's asking, again, how long, it tells you already kilometers per what? This would be hours, so I know it's 2.5 hours. Again, the same thing, it gives me the hours right here. For this one, it's asking for how fast did I go? Well, I know my distance is right here, kilometers, and we converted this one. In your question, the question I gave you, I converted it already to hours, so you didn't have to do that. 7.5 kilometers. And this last one was a bonus question, and you had to convert the time to seconds in order to get the correct answer, which was 10 meters per second. All right, we're going to be switching gears now. We're going to be talking about velocity and acceleration. Now, we've been talking about motion, and motion has to do with an object moving in a particular direction. The quick videos that I showed you of myself being stupid at the beginning of this presentation is an example of what we're going to be talking about today, and that is velocity. We're going to stick with velocity today, and we'll talk about acceleration on Thursday. So what is velocity? We know that the speed of an object refers to the distance the object goes over a given amount of time. However, when we're talking about velocity, it's taking that same definition of motion, but it's adding something else. So it refers to the distance an object moves over a given amount of time. That's the definition for speed. But now we're adding in a certain direction. So the examples that I gave you at the beginning of this video, I was running in a straight line. I was jumping up and down. I was riding a bike. Velocity refers to not only speed, but also the direction of the moving object. So if we have this jet plane right here, it's giving us examples of velocity because it's not only moving in a straight line, but then if it moved in a straight line forever, it would crash, but it has to pull up and change direction. It's still in motion, but now the direction has changed. Therefore, we now call this velocity. So let's think of it this way. If I have two objects, I have these awesome dragsters right here, and then I also have this F1 car over here. These two types of cars can move at the same exact speed. Let's just be totally unrealistic and say that they move at 250 miles per hour, which they both do individually, but you're not going to catch this one doing that around a curve. But let's say 250 miles per hour. If they're going in different directions, this one is only in a straight line. Let's say it's heading north. And this one is going 250 miles per hour around corners, north, south, east, west. They're going to have different velocities. Now, in scientific speak, it's just one's moving in one direction, one's moving in the other. Their answer is still going to be the same. So if I have a car traveling north, there's the key word. It's a specific direction, north. at 50 miles per hour, it has a different velocity than a car that's traveling, here's the next keyword, south at 50 miles per hour. The velocity of that object, it changes if the speed or the direction changes, or if both the speed and direction change. So a car traveling around a curve will change velocity even if its speedometer shows a constant speed. Don't dwell too much. I know some of you are like, what the heck did she just say? Just understand that if we are talking about velocity, it's talking about in a specific direction. If we're talking about just speed, everything's going in the same direction. So let's think about it this way. Think of all the ways that an aircraft can accelerate. We know that in addition to the way that cars accelerate, an aircraft also moves up and down, correct? Again, if an aircraft just went straight, that would be a big crash. So pilots have to maintain a certain amount of acceleration to keep a plane flying. So the aircrafts will have these instruments called accelerometers in them. Cars also have the same thing. When the accelerometers in a car sense that the car has stopped really, really fast, like basically going from 90 to 0, like a crash, the accelerometer will activate the airbags, and that protects the people that's in the car. So we have things in our car that are also measuring and testing what we're talking about. So what is acceleration exactly? I know I said we would get into this on Thursday, so you're right. I'm going to stop right there. Let's go back here. So again, the difference between velocity and speed, let's go back again to speed is measured in length units. Speed would be how fast something is going based on distance and time. And then our velocity is the same thing. We're just adding a change of direction. For today's assignment, all I need you to do is comment at the bottom of this video that you watched this video, and make sure your name is attached to it, and tell me one thing you did over spring break, and that will count as your assignment today. Talk to you later, guys.